So today's section is section 3.2, but this time it is part 2. We're going to go looking deeper into simplifying algebraic expressions, and this time really using the distributive property first before we start even simplifying any other expressions. So the first thing that we want to look at is we're just going to review some concepts here. The three concepts that we're going to look at are our like terms, our coefficients, and our constants. Remember for what we learned in the first part of section 3.2 that each one of these pieces here that are separated by addition or subtraction, these things are all called terms. No matter what they are, they're all called terms. But specifically, we have things like terms, coefficients, and constants. And if we look at this list, remember like terms have anything that share a variable, share the same variable, not just any variable, but share a variable. So our like terms in this situation are 3x and 4x. Those share the same variable. Now if we look at the coefficients, the coefficient is now the number that's multiplied in front of the variable. So in this case we have a coefficient of 3 and we have a coefficient of 4. And then the last thing, we have constants, which are just plain numbers. So in other words, these are just numbers, which is the 2 and the 3. So we have 2 and 3. And these are just a little bit of review of what the pieces of an expression really are. So our like terms are terms that have the same variable in them. We have coefficients, which is the number in front of the variable. And our constants are just our regular plain numbers that are without variables. And before we even really get started with this lesson and continuing with the first part, is we need to remember how we're simplifying things. So what we need to do is we need to find like terms first. So we're going to find like terms, and we're going to use our commutative property, remember, and our associative property in order to simplify this. And in order to do this, remember we have our little catchphrase here is that we add the coefficients of our like terms and then keep whatever variable of the like terms. So let's rearrange this. First, let's identify our like terms as being 8 and 2x. And keep in mind we also still have constants 5 and 7. And so if we rearrange this using our commutative property, we get 8x plus 2x plus 5 and plus 7. We can then use our associative property to say, okay, these two things are the same. These are like terms. We have 8x and 2x. But we also know how to add 5 and 7, so we can also associate those. So as a result, if we add the coefficients, we get 8 plus 2 with the x plus 12, which is 5 plus 7. And then we can add those coefficients together and get 10x plus 12. And then there's our simplified form. And then now what we're going to look at in our next example are a few examples of using our distributive property. And so if we look at this expression, there's one thing that's really generating a problem here. In order to be simplified, we have to have no like terms and no parentheses. And when we have a number that's multiplied out in front of a set of parentheses, what we need to do is we need to use the distributive property. So our first step is to recognize using the distributive property and then use the distributive property. So what we need to be able to do is we need to properly use the distributive property that we've been using for a little bit now. And so we recognize here that this is multiplication, so we say 3 times n and then 3 times 4 times m. And if we write that out again, we get m plus 3 times n plus 4 times m and then multiplied by 3. Now this is exactly what we've done before in the last couple sections, is that we have something here that we can actually multiply. And so we can actually multiply 4 and 3 together. So when we rewrite this, we get m plus 3n, that can't be simplified, plus 12m. And so now once we distribute, what we're going to do then is we're going to actually go ahead and simplify using everything that we just learned using like terms. So the only difference between part 1 and part 2 is, first of all, what we need to do is we need to use the distributive property. We need to get rid of those parentheses with quantities that we don't know, and the way that we do that is using the distributive property. So we can go ahead and recognize our like terms as m and 12m. Remember, this m has the imaginary multiplied by 1, or our 1 as a coefficient. So if we reorganize these, we get 1m plus 12m plus 3n. Associate these two things. Again, add the coefficients, keep the variable. So we get 13m plus 3n. And then there is our simplified form. We don't have any like terms because m and n are different variables, and then there's no parentheses anymore. So really our two steps here is, before we can simplify using like terms, we need to get rid of parentheses using our distributive property. Okay, so here we go with another example. So again, the first thing that we want to make sure that we're doing is distributing. So distribute first, and then simplify. Because of part of simplification is actually using the distributive property. So in order to properly use my distributive property, I kind of make sure I do this piece here by itself first. I can't forget about this plus p over here because it still exists. But what I'm really going to focus on is this piece right here, the 4 times q plus 8p. Now I can do this just like I did before in section 3.1 and distribute. So I do the 4 times the q and then 4 times 8p. So I'll write that out. 4 times q plus 4 times 8p, which we recognize that's still 8 times p. And then again, we can't forget about this plus p. Okay, that still has to carry down. We can't forget about that. That's still part of our original problem. So even though we distributed, we can't forget about that piece there. So again, I can combine a couple of these things where I can do some multiplication. So I can multiply 4 times 8 pretty easily. So I get 4q plus 32p plus p. Now remember, what's unique about this p has a coefficient of what? Has a coefficient of 1. So this is really a 1p. So again, if I use my associative property here, I don't really have to commute here because these are already next to each other. So slap some parentheses around here and add like terms. And in order to add like terms, I add the coefficients and keep the variable. So I plus 32 plus 1, 33, add the coefficients, and then keep the variable. And again, I don't have like terms, and I have no parentheses, so therefore this is simplified. Now this section here, part of the simplifying expressions, comes the more difficult stuff is when we start using negatives and everything like that. So what we need to do is we need to remember something here. So when we're dealing with subtraction, we don't like subtraction. Subtraction is a little bit more difficult. So we have to remember what we did before with our integers, and we need to get rid of our subtraction. And so in order to get rid of subtraction, we have to create addition. Now we don't really create addition because our property of subtraction, or our idea or our concept of subtraction, really comes from addition. So what we need to do is our little catchphrase that I've told you before is we need to add the opposite. And so when we talk about adding the opposite, we understand that 4 minus 16 really with addition is 4 plus a negative 16. And this is something that we're going to have to recognize because when we use the distributive property, we actually need to identify what we're actually distributing. Because even though some of you are looking at this and saying, okay, well I'm distributing 3, watch what happens when I change my subtraction into addition by adding the opposite. So what I'm going to come up with is I'm going to come up with 5, and add the opposite here, plus negative 3 times y plus 7. So now you see I'm not actually distributing a 3, but what I'm doing is I'm distributing a negative 3. Because really what's happening when I'm subtracting something from that entire piece, so this whole thing is treated as one big thing, since I'm subtracting that, what I'm going to do is I'm going to add the opposite, and we see that it's actually going to become a negative amount. And so when I add the opposite, we can see that that negative, or that subtraction, turns to addition, and that positive 3 that we thought we were going to distribute actually becomes a negative 3. And that negative 3 is what we're actually going to distribute. So we take this negative 3 and multiply it by y, multiply it by 7, and when I do that, I get 5 plus negative 3 times y plus negative 3 times 7, because that's how I use my distributive property. Remember, I multiply by each term and keep the operation, which is here. And so when I simplify what I can, I get 5 plus negative 3y plus negative 21. What I should recognize is I have a constant here and a constant here, so I can get those close to each other. So I get negative 3y plus 5 plus negative 21. I can associate here because I can add 5 and negative 21, which I can't add those to negative 3y because we now understand the difference between a like term or a variable term and a constant. And so we end up getting negative 3y plus negative 16 as our simplified form. Again, what we're seeing here is that we're seeing that when we're subtracting, we need to really get rid of our subtraction. So anytime you see subtraction, get rid of it, change it to addition, so that we can see that numbers that we think are positive really end up being negative. And so that's why we get negative 3y plus negative 16. And then so finally, we have one last really difficult example. And again, I highlighted this caution here because what we want to do is we want to get rid of subtraction. So get rid of any subtraction that we can. So we're just going to go through here and we're going to add the opposite. So here, this is not subtraction, that's a negative, so that's okay. So I'm going to add the opposite here, and I'm going to add the opposite here. So when I do this, what it's really best to do is just rewrite the problem, and I get negative 8e plus negative 4 outside the parentheses times 2f plus negative 5 times e. Okay, so far so good. So really all I've done is I've rewritten the problem in terms of addition rather than subtraction. And that's exactly what I wanted to do. That's why I really want to use caution whenever I have a subtraction problem. Turn that subtraction into addition. Remember, add the opposite. So now what I can do is I can go ahead and I can distribute. So what I'm actually distributing instead is a negative 4 times 2f and then a negative 4 times negative 5e. And if I write that all out, I get negative 8e plus negative 4 times 2 times f plus negative 4 times negative 5 times e. Now remember, I'm using parentheses so that I can separate our negative signs so I don't get confused on what's negative, what's a subtraction, and all that kind of stuff. Okay, so I can go ahead and multiply where I can. So I get negative 8e plus negative 8 times f, because negative 4 times 2 is negative 8, and then we keep this variable here, plus negative 4 times negative 5 is a positive 20, and then times e. Okay, now that I have all my multiplication out of the way, now I can look for like terms. I have a negative 8e and a 20e. Those are like terms, where this 8f is kind of all, or negative 8f is all by itself. So if I reorganize these, I get negative 8e plus 20e plus negative 8f. And then what I can do here is I can associate these. These are like terms, so I can add them together, I can combine them, I can add like terms. And remember, when I add like terms, what I'm doing is I'm adding the coefficients and then keeping the variables. Adding the coefficients, keeping the variables. Coefficients of negative 8 and positive 20 will combine to give me 12, positive 12e plus negative 8f. Now, some of your books and things like that and examples would show that 12e minus 8f. That's perfectly fine, but what I want you to do is I want you to not write anything in terms of subtraction. Try to use addition whenever possible. And that's pretty much going to do it for section 3.2 now that we've done parts 1 and part 2. So just remember, what we want to do is the first step that we always want to make is we always want to distribute. So distribute. And then second, then we move to simplification. So simplify like terms or constants. We can't forget about those constants either, because if they're just plain numbers, we can either add those or do whatever we need to do with those. So distribute and then simplify. And then, whenever necessary, get rid of subtraction.